When working with Power Designer data models, you can easily move between the different levels of abstraction by generating one model type from another. Thus, you can reverse engineer an existing database into a physical data model, and then use that PDM to generate a CDM or LDM to provide an implementation-neutral representation of your data system. You could refine your data system in the logical or conceptual model, and then generate a PDM targeted to the same or a different DBMS. Or, of course, you could design a system from scratch, using a CDM to discover the various entities required and the relationships between them, and then generate a logical or physical data model in order to move closer to an actual implementation. Here, we're looking at a simple CDM with an inheritance and a handful of relationships between entities. To generate another model, I select Tools, and the type of model I want to generate. Note that in addition to an LDM or a PDM, I can also generate another CDM or an object-oriented model. This time I'm going to generate an LDM. I enter an appropriate name for the new model, and then take a look at the model options that I can specify for it. I'm going to use the ER notation. I'm not going to allow many-to-many relationships in the LDM, although this is an option. Now I'll take a look at the other generation options. I want to make sure that there will be a check on the model that I'm generating, and also that I'd be saving links between the two models so that I'll be able to sync any changes in one to the other. The other tabs allow me to specify additional models that provide target objects for shortcuts, and also to select the objects, by default all, that will be generated. Here then is the generated LDM. Now, if we take a look at the models side by side, we see that inherited attributes have migrated to the child entities and that foreign keys have migrated along relationships. In addition, and because I have not allowed many-to-many relationships in the LDM, the works on relationship has been replaced by an intermediate entity. Now, we'll generate a physical data model from the LDM. The process is the same as for generating from a CDM, but we must choose a DBMS as a target. Here I'm generating for Sybase ASE. There are more generation options here, but we're not going to go into detail about them in this video. Now we'll look at the LDM and PDM side by side. Entities are generated as tables and attributes as table columns. Primary and foreign identifiers are generated as keys, and relationships are generated as references. Note that no table has been generated for the activity entity, and the inherited attributes have been generated as columns in the child tables. I can change that by opening the property sheet of the inheritance in the LDM, and, on the Generation tab, selecting the Generate Parent checkbox. Note that I'm leaving the generation of the children enabled, along with their inheritance of all attributes, so we can expect to see the start and end date columns in the activity, project, and task tables. Now I can regenerate the PDM. This time around I'm going to update the PDM I've already generated. The Merge Models window opens to allow me to inspect the changes that I'll be making to the PDM. Here we'll see that an activity table will be added. I can reject any change by unchecking its checkbox, but here I'm going to accept them all. Now we can see that the activity table has been added to the PDM, and that, as expected, it and the project and task tables all have start and end date columns. In this video, we have seen how you can generate the various types of Power Designer data models from each other. For more information, see the Data Modeling Guide and the Linking and Synchronizing Models chapter of the Core Features Guide.